app server, which needs to talk to the web server, and if I keep them all on the same host, their networking occurs over the bus speed, right, over the VM bus and not over the network. So useful for performance. The third one is a virtual machines to hosts rule. And for this, I actually have to create some stuff here, a cluster VM group and a cluster host group, which is what this groups manager is. So if I have a, I don't know, let's do VM6 here in this DRS group, VM6 group, right? And I want to say, okay, here's a host group. I want to say ESX1 and 2 are in this host group, sum of my hosts there. When I come down and create a rule, that would be a virtual machines to hosts rule, the VM6 group must run on hosts in the sum of my hosts group, or should, or must not, or should not. This is essentially a much more granular version of the other two affinity rules. Okay, and over here in Groups Manager, I can do some more information. The same thing. This, and that is the same thing. But these two are the ways in which I identify as stuff moves around and is dynamically shifting around inside of my cluster to make sure that virtual machines don't end up on the same host or do end up on the same host. Do I want to set automation levels here that are specific to DRS? Maybe now, instead of just having the entire cluster fully automated, I want to have just certain VMs that are fully automated. Power management settings, just like we saw before, and specific host options with power management settings. EVC settings, right? I'm still disabled here, but you would be enabled, and then the swap file location. So all of this are the settings that you have to be conscious of whenever you're creating that cluster. And I will tell you, you can make some really painful, awful decisions that would really cause some problems here. So be very intelligent whenever you create this cluster. Try not to create too many affinity rules. Especially in smaller clusters, affinity rules can cause some real problems in that it doesn't give the cluster, it reduces the number of options that the cluster has for where to put stuff. Same thing with shares, reservations, and limits and resource pools. You know, a resource pool is effectively a piece of a cluster. Okay. My cluster here, for example, has, if I look at the summary here, it has, what do I have here, 22 gigahertz of CPU, 10 gigabytes of memory, and 550 gigabytes of storage. That's the maximum supply of resources that my cluster has. So a resource pool then, as I mentioned, is a piece of that cluster. Well, let's say I want to create a resource pool for those marketing people. Right? And those marketing people need to have, I don't know, 7627 megahertz of CPU and not all that RAM. We want to give them a little bit of RAM. There's some RAM. So now I've created a resource pool, and those marketing people can now do whatever they want as long as the amount of resources that they use are equal to the amount of resources that or less than the amount of resources that I've assigned to that resource pool. Now there's no VMs in here. Right? If I take a VM and move it into that resource pool, right, now I'm going to have resource utilization. I power on this VM, I'm going to make use of this. So I'm now essentially providing kind of some hard limits for those marketing people so that they can create as many VMs as they want, as long as the VMs that they create don't exceed the reservation that I've limited them to. Okay, I can create sub-resource pools too. The marketing people want to go through here and, I don't know, project X people. So they can then, from the reservations that I've given them, then give more reservations, and it can go on to infinity. So this provides a way to take the sum total of all the stuff that makes up that cluster and break it down into logical